see from the worksheet here, we went over the steps or sort of the rules or processes for adding and subtracting fractions. And the main idea is basically it requires common denominators, and we worked on getting those, and then I passed out this worksheet. I'm going to go through the solutions for just adding and subtracting the fractions here for all of these ones. Then we want to look at solving equations that involve fractions. So that's where we're going to go today, because if you notice, there's kind of a pattern. So it's like we started out with whole numbers, and then we learned how to solve equations with them. Then we introduced the negative numbers. Then we learned how to solve equations with them. Now we're introduced fractions. We're going to learn to solve equations with them. Okay, so it's just getting familiar with working with each type of number and how to use them inside of equations. And then after this, so we got our first exam coming up on Thursday. So real quick, actually, since I'm on the topic, don't forget that this week you want to make sure that you go take a look at the practice test. And so it covers modules or chapters 2 through 4. So if you scroll past, it's in the module section. You have to scroll past chapters 2, 3, and 4. Right under there, you'll find your exam 1 module. Talk a little bit about what's there, but then here's a practice test. So make sure you get a copy of that. I don't bring printed copies usually. Most of you guys probably won't even print out a copy anyways. And so if you want to print out a copy, you can, but it's there. And you want to take a look at that this week. Because it's going to be most similar, or it's going to be similar to what the exam will be like. So there's no surprises on it. This is a little longer than an actual exam. You'll see it's like, I think it's lots of examples, right? I think it's like 4 pages. And most of these will look pretty similar to the problems that you've encountered on the quizzes. It's not like I'm going to try to like trick you or throw anything crazy onto the exam. But you'll just want to make sure that you take a look at that. Give it a try. My recommendation is don't look at the solutions until after you give it a try. You really want to treat it like an actual exam if possible. So print it out, take it, then come back and look at the solutions afterwards and see how you did. That gives you a better idea of kind of where you're at. So any questions about the test or the practice test or anything like that? Because then we're taking our exam on Thursday. So today we'll get into some equations with fractions. Tomorrow we'll do some more practice. I'll give you another practice worksheet tomorrow, and then I was thinking I'll collect the one tomorrow for extra credit if you want to come in tomorrow and get some extra credit. And then Wednesday will just be a review day. Okay? All right. So let's go back to where we were yesterday. All right. So the first examples that I put on the worksheet, those were common denominators. So nothing too tricky when you have common denominators because they're common, so you can just combine them. So if you have 2/5 and a fifth, that's just going to come out to be 3/5, right? So you add the numerators, but the denominators stay the same. The denominators are almost like units. We're all working in fifths here. So I got 2/5, I throw in one more, I got 3 of them. You do have to be careful with the signs. So again, anytime I see like plus a negative, what can you immediately do there? So anytime I see plus a negative, I always immediately just rewrite it as subtraction, right? So I would just say, okay, so this is negative 1/8. This will become minus 3/8. Now, addition and subtraction, now remember, there really are no rules. You just have to think about it kind of on the number line or in terms of money or whatever. If you're at negative 1 and then you take away 3, where are you going? More negative. So this is going to take you back to where? Negative 4/8. So that would be the solution, but it's not correct because why? It's not most correct because it's reducible. Because these are both divisible by 4. So we need to reduce that. It'll come out to be negative 1/2. Okay? So again, I'll just go through these. Just ask questions or stop me if you need as we go. Right. So always make sure you check to reduce. Then we got, this one was a little tricky. So it's like x over 4. This one started introducing variables, which is something we'll see more and more as we go. So if I have, here I actually have common denominators. So since they're common denominators, we can combine them into a single fraction, but x and 3 are not like terms, so we can't actually add them. So you could take it this far, but then that's as far as you could go. It's just not, you can't do anything with it. unless I were to actually like give you a value of x, you know, I'd say evaluate this when x equals 5 or something. Then you could plug in 5 and you could simplify it. But without that, they're not like terms, so you can't combine them. All right. Okay. Then if you run into mixed numbers, is that a problem? Not really. This one's actually pretty straightforward because there's no like carryover or anything. Because what is this one going to come out to be? Can you tell already? It's got to come out to be what? Well, 1 and 3 make what? 4, and then 1/5 and 1/5 are going to be 2/5. So it's definitely going to be 4 and 2/5. So if you have an example like this, you can, if it's an example where like you can just combine them right away. What happens is it gets harder. Like if this was 3/5 and this was 3/5, then they'd add up to 6/5, so there'd be carryover. I could actually create another whole number. So when I see these, I usually just go and I convert them because 5 times 1 is 5. You know, plus 1 is, so this is 6/5. 5 times 3 is 15 plus 1 is 16. I'll just combine them as impropers, so this would be 22/5. And then you can just flip it back into a mixed number, because how many times does 5 go into 22? 4 times, because 4 times 5 is 20, with 2 left over. So if you can add them up quickly, you know, and there's no carryover or anything like that, that's perfectly fine. Like this is always going to be 4 and then 2/5. But if as the fractions get more complicated, or if there's carryover, or you end up having to borrow, it's a lot easier just to go into impropers and then convert back at the end. So then this is one of those examples, the next one I had given you. So 8 and 3/7 minus 4 and 4/7. You can't really use the same strategy because you know you can do 8 minus 4 is 4, but then if you try to do 3/7 minus 4/7, you can't do that, right? Because you only have 3/7 here, so you can't take away 4. So you'd end up having to like borrow or something. So that's why I always just go to impropers. Even though the numbers can get big, it's not really a big issue. So 7 times 8 is 56, plus 3 would be, this would be 59/7. And then 7 times 4 is 28, plus 4, that would be 32/7. So then you just subtract them like normal. So 59 minus 32, that takes you down to what, 27? Sevenths. Okay, and then now we would just have to, that's technically not wrong. You know, just like 22/5 is technically not wrong. But if you want to turn it back into a mixed number, well, how many times does 7 go into 27? It only goes in 3 times. 3 times 7 is 21, so there's 6 left over. So that'd be the mixed number answer. I think I didn't tell you how to represent them, but if I don't tell you on an exam, like if I don't ask specifically for mixed numbers, you can just give me the improper fraction. It's fine. But occasionally I do ask for it, just like on the quizzes. Okay, so far so good? Any questions? Perfect. So the next one, 4 over 21 minus 19 over 21. Then this one, you just got to deal with negatives, positive. You got 4 and you go subtract 19, where are you going? You go negative 15. So, and it doesn't really matter where the negative is. You could put the negative in the numerator, but typically just the most common thing to do is that if the whole fraction is a negative, we just pull it out to the front and just show, oh, this is a negative quantity. So, but technically, if you put it like this, that's not really wrong. It's just not the most conventional way that you see fractions written. So, okay. So far, so good? All right. Then what happens, though, is you get into situations where you don't have common denominators, so then you have to go find them. So looking for least common denominators. The first example, I didn't actually want you to combine these or anything. I just wanted you to find the least common denominators. So like the least common denominator between 7/12 and 5/8. What's the least common denominator between 12 and 8? So, remember, that would be the least common factor. Remember, if we're going to get least common denominators, eventually what we're gonna do in the next part is we need to change these so they're the same. But the problem is you can't go down. Like, I could divide this by 6 and take it down to 2, but 7 can't be divided by 6. And I could divide this by 4 and take it down to 2, but 5 can't be divided by 4. So we have to go up. Yeah, so we're going to go up by factors of 12 until we find something divisible by 8. So 12 is not divisible by 8, but 12 times 2 is 24, and 24 is divisible by 8, right? Because this one could get there by doing times 2. This one could get there by doing times 3. So 24 would be our LCD there. If they're pretty straightforward, it's not too hard to figure it out, but sometimes they can be pretty complicated. Like the next one I gave you was 13 over 30 and 25 over 42. So if I'm trying to find the LCD between 30 and 42, okay, 30 and 42, that could take a while because 42 is a big number and 30 is a big number, and we could go up by multiples of 42 if you wanted, but what's the strategy we can fall back on for bigger numbers like this? We can go back to our factor trees to get the least common denominator. So we can say, okay, so 30 is 3 times 10, and 10 is 2 times 5, right? And 42 is what? 2 times 21, and 21 is 3 times 7. Okay. So if you remember how we use these, we say, okay, so 30 is 2 times 3 times 5, right? We just keep the prime factorization from the bottom of our tree. And 42 is 2 times 3 times 7. So then to build the least common multiple, or in this case it's the least common denominator because it's in the denominator, well, first you look at what they share, right? So they both have a 2, so a 2 is in there. And they both have a 3, so a 3 is in there. And then they don't share anything else in common, so what do? You just toss in all the rest of the factors that they don't share. So that means I'm going to have to throw a 5, so it's divisible by 30, and a 7, so it's divisible by 42. And then you just take the product of all of those, and then 2 times 3 is 6 times 5 is 30 times 7. It looks like it's 210 is your answer. So, okay. So this one would be pretty complicated to work with. You'd have to bring 30 up to 210, and you'd bring 42 up to 210, and then you'd end up getting some really big numbers. But I didn't actually ask you to add or subtract them or anything. I just wanted you to find the LCD. So normally I'm not really going to give you tons of examples where the denominator is super complicated. But if they do get kind of big and complicated, you can still tackle it. You just got to fall back on the prime factorization strategy. Something like this is probably more like what you see on the quiz. It's usually not too terrible. All right, so any questions so far? So we got all the common denominator stuff up there, finding LCDs. Any questions on anything we did up to that point on the worksheet? Everybody feeling all right? Okay. Perfect. So now, then we get into the examples where there are not common denominators. So now we've got to change our fractions. We've got to make them look alike. So if I'm looking at 1/2 plus 1/7, I want to get an LCD. What is the LCD here? We need to bring these both up to 14. Okay. Well, how are you going to bring halves up to 14? It's going to need a 7, and if you multiply the bottom by 7, you have to multiply the top by 7. So I'm going to give it a 7 over 7. That'll bring the 2 up to 14. Then, what about 1/7? What does it need? Yeah, the 7 is going to need a 2 over 2 to bring it up to 14ths. All right. So then what it becomes, so 1 times 7 is 7. 2 times 7 is 14ths. That's what we wanted. 1 times 2 is 2. 7 times 2 is 14. So essentially what we do is we create unreduced fractions so that they have the same denominator. Because both of these are reducible. Like we could reduce them back to where they started, but we actually don't want to. We unreduced them on purpose, so now they're both in 14ths. And now we can combine them because if you have 7 14ths plus 2 14ths, that will be 9 14ths. And that's the solution. It's not reducible. Okay. Any questions on that one? You feel okay about that? All right. So then I had 7/12 minus 9/16. So that's getting a little bigger, although these share a lot of common factors. So you don't have to go too far. So I might just try multiples of 16. So 16 is obviously not divided by 12. 16 times 2 is 32. Is 32 divisible by 12? No. 16 times 3 is 48. 48 is divisible by 12. Okay. So then, well, we're gonna go up to our LCD of 48. So you always have to go up. So what does a 12 need to bring it up to 48? It needs a 4. So I'm going to give that one a 4 over 4. And what is a 16? Well, we just figured out. What does 16 need to bring it up to 48? It needs a 3. So we'll give that one a 3 over 3. Remember, whatever you do at the bottom, you got to do the top. So we're keeping the fraction the same value. We're just changing its denominator. So 7 times 4, this would be 28 over 48. And 9 times 3 is 27 over 48. So we unreduced our fractions to get them up to common denominators. Now we can combine them. That one's pretty straightforward. 28 minus 27. Looks like the answer is just going to be 1 out of 48. So. All right. What do you say? All right. If you're going to get into examples with negatives, you just got to remember the rules. I deal with my signs first, and then I worry about common denominators after that, typically. That's the way I handle it. Because, for example, if I ever see minus a minus, what do we know to do with that? Yeah, just turn it into addition, because I know that's what it's going to be anyways. So this is negative 9/16. This will become plus 4/5. All right. Now we can worry about least common denominators. So I got to bring 16 and 5 up to something that's divisible by both of them. What is the LCD here? Do I find it? It's 80. So the LCD here is 80. And so we need to bring them both up to 80. So how do you bring 16 up to 80? What does it need? It needs the whole 5 over 5. Okay. And what does 5 need? Well, we know now. It needs the 16. Yeah, so examples like this, see 16 is not divisible by 5 at all, and 5 is prime, so we know that we're just going to have to give the 5 and 16 a 16 and 5. They don't have any common factors. So anyways, so now we just multiply. So this is going to be negative times a positive, so it's going to stay negative. It's negative 45 over 80. This is 4 times 16, what's that, 64? Yeah. That becomes 64 over 80. Now we can combine. Negative 45 plus 64, is this going to be addition or subtraction? This going to be subtraction because they have opposite signs, right? So I'm at negative 45. I'm adding 64. It's going to take me positive, but not. It's just going to be, this is the same as 64 minus 45. And what does that come out to be? I think 19. Positive 19 out of 80 is your solution to that one. All right. Questions on that one? Okay. So remember, you always got to bring them up to bigger denominators. What if you see something like, what if whole numbers get thrown into the mix? How do you handle that? What do you do if whole numbers get thrown in there? Yeah, you just write them as fractions, and then, so 1 is like 1 over 1, and if I want to get a common denominator, I just need to bring that up to what? Yeah, that's just going to become 9/9. 1 is the same as 9 over 9. Okay, so you just treat it like a fraction, put it over 1, then just give it the denominator it needs. It's easy because the common denominator is just going to be whatever the other one is, if you got a whole number and a fraction. So you just bring it up to nines. 1 is obviously 9/9, right? So
Anyways, then that one becomes pretty straightforward. 9/9 minus 5/9. Not too bad. 4/9. Okay. All right. So far, so good? Okay. Then, so whole numbers aren't a problem. You just put them over 1 and work with them exactly the same way. If you get into mixed numbers, is that a problem? Not really. Mixed numbers aren't a problem because we can just immediately rewrite them as fractions, like impropers. So with these mixed numbers, I would just convert them first. You could do common denominators first if you want. I usually convert them first. So 4 times 3 is 12 plus 1. This would become 13/4. And then 3 times 6 is 18 plus 1. This becomes 19/3. But we still have a common denominator problem here. So what do we got to do? We need to bring these up to what? What's the LCD? Yeah, the least common denominator here is 12. So what's 13/4 going to need? It needs a 3/3, so that 4 can be brought up to 12. What does 19/3 need? It needs the 4/4. Right. So then we can bring them up. So 13 times 3 is 39/12. And then 19 times 4 is 76. 76/12. Now we can add them together. So 39 plus 76 equals 115/12. That's technically not wrong because that's the answer. But we could turn it into a mixed number. So how many times does 112 go into 115? It goes in 9 times because 9 times 12 is 108 with a remainder of 7. So then it looks like it would be 9 7/12 if you had to convert it to a mixed number. So that was a little messier. The numbers get a little bit bigger, but the process doesn't change. So it's like as long as you follow the steps, get the mixed numbers into impropers, then bring it up to LCDs, combine them, then you can worry about this at the end, because that's technically the correct answer. But if you really had to, you could go back into mixed at the very end. Yeah? Questions on that one? Where those numbers came from? All right. So then here we had 2 2/3 minus 3.5. So I would convert again. So 3 times 2 is 6 plus 2 is 8. So it becomes 8/3. 2 times 3 is 6 plus 1. This becomes 7/2. And then what do we need to bring this up to? What's our least common denominator? We've got to bring them up to 6. So 8/3 is going to need a 2/2. 7/2 is going to need a 3/3. So then 8 times 2, this will become 16/6. 7 times 3, this will become 21/6. 16 minus 21. So I'm at 16. I'm taking away 21. Where am I going to go? I'm going negative. And 21 minus 16 is 5. So it's going to take me back to negative 5/6. That'd be your solution there. What do you say? Seem okay? What questions do you have with working with fractions, with unlike denominators? Okay. So you should be able to multiply, divide, add, subtract fractions with common denominators or without common denominators. Common denominators only matter in addition and subtraction, though. In multiplication and division, it doesn't matter. So you only have to worry about common denominators if you're adding and subtracting. Yes? Okay. Now, I told you, once we know how to operate them, we just want to do some practice with solving equations with fractions. But you already know how to solve equations with fractions because you already know how to solve equations, and you already know how to work with fractions. So this actually isn't new at all. It's just putting them together. So as an example, let's say we had, like x minus 2/3 equals 1/2. It's an equation because it has an equal sign. If it has an equal sign, that means it can probably be solved. And how do you solve equations? What's the goal? You get the variable by itself, right? How do you get the variable by itself? Well, you look at what's going on that side of the equation, and you do the opposite operation to get rid of anything over there that you don't want. Okay? So my goal is to get x by itself. Right now there's an x minus 2/3. So how would I go about getting rid of that 2/3? So we would add 2/3 to that side. Of course, if we do that, what does that mean? Yeah, it cancels on that side, but we also have to add 2/3 to the right-hand side. Okay. So over here, we'll just have x. The only thing is that it gets a little more complicated because now we have to clean up the other side. Because with fractions, it's not as straightforward when what's going on the other side. Because here we don't have common denominators. But that's okay because we can deal with that, right? So what do we need to do on the right-hand side now to clean that up? They need to be brought up to what? Sixths. Because there's a 2 and a 3, the LCD is 6. So the 1/2, I need to give a 3/3. And the 2/3, I need to give a what? 2/2. Right? So then, this will become 3/6. This will become 4/6. And so what's our answer here? Looks like 7/6 would be your solution. Or 6 goes into 7, 1 with 1 left over. But I'm okay with the impropers. So, okay. So the process doesn't change. You're still solving the equation by doing the opposite operation there. It's just that there's going to be a little extra work typically because on the right-hand side, you'll have to clean up a little. All right. What do you think? Seem okay? Okay. I'll show you another one. So let's say we had like 5/9 equals, say, y plus 1/15. What do you think? Yeah, so I've got a plus 1/15 on the right-hand side. Doesn't matter where the variable is, right-hand side or left-hand side. Right now I got a plus 1/15 on the right-hand side. I want to get rid of that so I can solve for y. So absolutely, we'll just take away 1/15 from that side, which means we also have to take away 1/15 from the left-hand side. So on the right-hand side, that'll be gone, which is what we want. Now on the left-hand side, we have a 5/9. We started at a 5/9, and then we're going to take away the 1/15. Okay, so it's just important that you get the order right because if 5/9 was already over there, it needs to come first in the statement because we were taking away 1/5 from the second. Now, though, we got to clean these up a little bit because they don't have common denominators. So what is the least common denominator between 9 and 15?
45.
Yeah, we can take them up to 45. So 15 doesn't work, not divisible by 9. 30 doesn't work, but 45 works. So we need to bring these up to 45 in the bottom. So what does 5/9 need to be brought up to 45? What does 9 need? It needs to be multiplied by 5, so we'll give that one a 5/5. How about 15? What does it need? 15 needs a 3 to bring it up to 45, so we'll give that one a 3/3. Okay. So far, so good? Okay, so we subtracted 1/15 from both sides, but they don't have common denominators, so we have to get there. We're going to bring them both up to 45. 9 needs a 5 to come to 45. 15 needs a 3 to bring it up to 45. Now we just got to finish it off. So 5 times 5, this will become what? This 5/9 becomes 25/45. 1/15 becomes 3/45. Notice I'm not changing my sign. It stays subtraction the whole time. So now 25 minus 3, that gets us what? 22/45. You should check to make sure that it's not reducible. But I know it's not reducible. How do you know it's not reducible? Because what's 22 divisible by? 2 and 11, that's it. And then 45 is only like 5s and 9s and 3s. So there's no common factors in between those two numbers. So we're done. And it's a proper fraction because the number on top is smaller. So we don't have to do anything at all there. What do you think about that? Seems okay? Okay. Probably division and multiplication are actually simpler just because multiplying and dividing fractions is typically easier. So if we had something like, what you will start to see now is you'll start to see something like we'll throw in, say, actually, there's two ways you can solve this. But right now, it's the same strategy, right? So on the left-hand side, I've got an x, and then it's being divided by 3, but I'm trying to solve for x. So what do? Right now, it's divided by 3, so how do you get rid of that 3? Yeah, so this is like division by 3, so we can just multiply this side by 3, and then we'll just multiply this side by 3. Okay, and then that'll get rid of your x's. So then over here, 2/5 times 3, 3 is just like 3 over 1. So what does this become? 6/5. And that's your answer. That one happened to have a fraction on the other side. It may not be, sometimes it'll be even simpler. You'll see something like y over -3 equals 5 or something like that. Right? We just haven't seen ones quite like this before, but now that we have fractions, we can handle it. What do you do with the -3? Yeah, you're just going to multiply both sides by -3. So multiply by -3. And you want to send the sign with it. So if it's a negative, you should multiply it by a negative so that you get that sign out of there. 5 times -3 would be -15. Like that. Okay. So if you see a variable divided by a number, that's fine. Just multiply it to get rid of it, and then clean up the other side. Okay. If it's addition, you subtract. If it's subtraction, you add. If it's division, you multiply. The one scenario that gets a little weird, but you can handle it, is let's say it was like 2/3 x equals 1/2 or something like that. So an equation like that, how would you handle that? Yeah, so on the left-hand side, that's 2/3 times x. So how do you undo multiplication? You just divide. This is why I showed you complex fractions last week, because they pop up when you're trying to solve equations that involve fractions. So it's 2/3 times x equals 1/2. We're going to divide the left-hand side by 2/3 to get rid of it, which means we also have to divide the right-hand side by 2/3. But a complex fraction we learned last time, how do you rewrite complex fractions? Just rewrite them as division statements. So 1/2 over 2/3. Remember, this big fraction right here, this just means division, right? And so we can rewrite this as 1/2 divided by 2/3. And now we just got to remember our rules for dividing fractions. What's the rule? You got to reciprocate, and you always reciprocate the second one, right? So we flip, we reciprocate the second fraction, the one that comes after the division sign, because we know that dividing by a fraction is the same as multiplying by its reciprocal, or its flip fraction. Yeah? And then multiplication is just what? Does it matter? These happen to have common denominators. Does it even matter, though? It doesn't matter, because multiplication is just what? Straight across. So 1 times 3 is 3. 2 times 2 is 4. And that'd be your solution there. All right. Seem okay? Okay. So last time when we did complex fractions, they seem kind of dumb, like why would you ever encounter them? But the answer is you encounter them when you're solving equations, because sometimes they pop up like that. But that's okay, because we're just going to rewrite it as division statements, and then we can handle that. So, yeah? Questions on either of those, or any of those examples? Okay. So the rules are exactly the same as before. You're just isolating the variable using kind of like the inverse operation. And then when you throw fractions into the mix, it just complicates it a little bit. You just have to remember with addition and subtraction, you need common denominators. Otherwise, it's kind of, these aren't really actually as hard, I don't think, because you don't even have to worry about common denominators when it's multiplication and division. So, everybody seem okay with that? If you don't have any questions, I'll just give you some practice, because that's what I got some equations here for you to give a try. All right, so I'll let you give these a shot. Yeah. You pass one down. So I'm going to go over these in the last 10 minutes. So if you want to stick around to see the solutions, I'll do those in about 15 minutes. And then, because tomorrow I'm going to bring another worksheet with some more equation practice, and that's what I'll have you try tomorrow, and you can turn it into me for some extra credit tomorrow. Okay. So give these a try, and we'll revisit them here in a few minutes. All right, so I know you guys are still working on it, but I just want to make sure I can get you the solutions before we leave today. So this one started out, it was equation with f plus 9/10 on the left-hand side equal to 2/5. Trying to solve for the value of f. Well, I got a plus 9/10, so what should we do to solve here? We would just take away 9/10 from that side, which is fine. We just also have to take away 9/10 from that side. So it's addition here, so we'll use subtraction to get rid of it. So then on the left-hand side, you'll just have f. On the right-hand side, we have 2/5 minus 9/10. And then that's not a common denominator, though. This is a subtraction. We need it. So what do we need to do with 2/5? We need to bring it up to, what's our LCD here? Yeah, in this case, sometimes one of them already have the LCD. You could go up higher than 10, but you don't need to, because 5 can be brought up to 10. So I'm just going to bring 2/5 up to tenths by giving it a what? 2 over 2. So then what you have is you'll have f equals, this becomes 4/10 minus 9/10. And then 4 minus 9 is what? Negative 5/10. And that's reducible because those are both divisible by 5. So this will become negative 1/2 for that one. Okay? So you see addition, you subtract, then you worry about the right-hand side. Got to get some LCDs so that you can put them together, and then you're good. Don't forget to reduce at the end. Negative 5/10 is technically correct. It's just not reduced. All right? Just stop me if you have questions as I go. Okay? Just if you have any questions about where any of the numbers came from while we did that, just let me know. Otherwise, I'm just going to kind of keep trucking so we can get these done before the end of the hour. So anytime you see a plus or negative, what do I tell you to do? Just don't deal with it. Yeah, just turn that into subtraction. Then you just want to solve the equation. Once you turn that into subtraction, you can just solve the equation like the first one never even existed. So just start from here. Now, if I'm right here and I've got s minus 1/2, how do I get rid of a minus 1/2? I would just add 1/2 to this side and add 1/2 to that side. So the 1/2s disappear on that side. You just have s. Now we just need to clean up this side. So what's the LCD between 9 and 2? we're going to have to go up to 18. So the negative 8/9, that'll need a 2 over 2 to bring it up to 18ths. And the 1/2 is going to need a 9 over 9. So then this will become negative 16 over 18 plus 9 over 18. Then we can combine them. You just got to figure out, okay, so if I'm at negative 16 and I add 9, where am I going to land? Yeah, it's going to stay negative, right? Because if I'm at negative 6, I add 9. I'm not going to get back positive. 16 minus 9 is 7. So, right? Did I do that right? Okay, and then it's got to be negative. So it'd be negative 7 over 18. That'd be your solution for that one. Okay? Questions on that one? Okay. I think the division and and the multiplication ones are actually a little easier. So like if I have y over 7 equals negative 21, well that's y divided by 7, so what do? Yeah, I just multiply that 7 on both sides to get rid of it on that side. And so then you just got to do, well, what is negative 21 times 7? It's 147, and then it's got to be negative, because a negative times a positive is always negative. Okay. All right, then the next one gets a little more complicated if you have fractions. Oops. So it was negative 2/9 a equals 16. So of course I was telling you before, well this is negative 2/9 times a, so how do you undo multiplication? Yeah, just divide both sides by negative 2/9. And remember, take the sign with it, because you want to get that sign out of the side with the variable. So on the left-hand side, you go negative 2/9 divide by negative 2/9, so you're just left with a. On the right-hand side, we'll rewrite this as a division problem, right? So that's 16 divided by negative 2/9. And 16 we can rewrite as 16 over 1, just to get them both in fraction form. Now the rule for dividing fractions, though, is actually I need to rewrite that as 16 over 1 times, and I need to flip the second fraction, right? And now we're just working with multiplying. This one can be simplified a little bit, right? Because 16 is divisible by 2, right? It's 8. And so then what we have on top is just what? 8 times 9 is 72. And 1 times 1 is 1, and it's negative, right? Because a positive times negative. So what's the answer here? It's just negative 72. Because anytime you end up with a number over 1, it's just a whole number. It's just 70. Just 72. It's negative. Positive times negative. Okay. So you divide the fraction out of there, but rewrite it as a division problem on the other side. Then you're just working with rules of dividing fractions. So reciprocates. Simplify if you can. Because if you didn't simplify, you'd come up with like 144 over 2, and then that would just become 72. So you don't have to simplify in advance. It's just your numbers get a little smaller. So, all right. Can I erase that, or are you guys still working on it, or do you have any questions there? Okay. All right. So then let me go to the next one. This one's not as bad. If I just got negative 4w equals 26. Now, notice in here, I didn't want any, I said don't give me any decimals. I want all fractions. So to get that negative 4 out of there, what do? Well, first I'll divide it out, negative 4. So on the left-hand side, it's just w left. Now over here, though, I've got this 26 over 4. If you try to divide 26 by 4, it's not divisible, right? So it's reducible, though. So this is like negative 26 over 4, but that's reducible because those are both divisible by 2. So it would be 13 over 2. That would be the improper answer. And then if you had to do a mixed fraction, 2 goes into 13 6 times with 1 left over. Okay. So if I specifically ask you, or a quiz specifically asks you to provide your answers as fractions, you still do the same process, divide by 4. But if this number is not divisible by 4, you need to leave it as a fraction. Reduce it, and then if you need to, you can convert it to a mixed number. Of course, this one's not too bad because halves work out. Like you could have done your calculator, it'd give you 6.5, and you guys are all probably understand enough to know that that's 6.5. So you could do it that way, but that won't always work out. sometimes you'll end up with really goofy decimals that you never be able to backtrack into mixed numbers. So, all right. All right, so that was that one. What about the next one where it was 3x equals 0? Well, how do I get rid of that 3? Divide by 3, which means I have to divide this side by 3. Well, what's 0 divided by 3? Yeah, it's just 0. 0 divided by anything is just 0. Okay. If you go back to the original equation, it makes a lot of sense. What's the only number you can multiply 3 by to get 0? Well, it's got to be 0. So 0 can be an answer. It's not an issue. Then we got another fraction one. So 7/8 m equals 1/10. Well, how do I get rid of that 7/8? It's times, so I will divide it on both sides to get rid of it. This is why we had that complex fraction conversation last week, because this is the same as 1/10 divided by 7/8. So I'll rewrite it as a division problem. And then the rules of division say that I should rewrite that again as multiplication of the reciprocal. So dividing it on both sides, rewrite it. Now we just have to take care of reducing. 8 and 10 are both divisible by 2. So 10 divided by 2 is 5. 8 divided by 2 is 4. So on top, you just have 1 times 4 is 4. On bottom, 5 times 7 is 35. And that would be your solution. All right. And then, that one all right? Any questions on that one? Okay, so then the very last one, if I have a whole number there, is that a problem? Not really. We're pretty good with working with whole numbers along with fractions. This is 4 times f, so how do you get rid of it? Just divide it out. And again, it creates another complex fraction, but if you just rewrite that as a division problem, it becomes a lot clearer how to handle it. So it ends up being 4/5 divided by 4 on the right-hand side. But 4 is the same as, right, we always write those whole numbers as fractions. And then, so which one gets flipped? Well, it's always the one after the division sign. So you write it as 4/5 divided by 4, then that 4 over 1 gets flipped, becomes times 1/4. Well, what happens with those 4, since there's one on top and one on bottom? They just cancel each other out, and your answer is just 1/5. Okay? So, if you didn't finish those, or you weren't feeling super comfortable, take a look over those tonight, and then tomorrow I'm going to give you some more examples, and you can give those a shot, and then turn it back to me. I'll give you some extra credit. All right? And that's actually all the material we'll cover between now and the test. So now it's just getting some practice in.